Hi, everyone, and welcome back to Backer Breaks It Down. In this episode, we're going to look at some examples of triangle similarity. We're going to determine whether two triangles are similar, and we're going to explain why they are similar. Starting with these two, because they're so similar. So clearly, they are similar, but why? Okay, so what I notice is these arc marks here. And these arc marks are indicating that those two angles are congruent. So I have a pair of congruent angles. I've also been given information about two pairs of corresponding sides. In the blue triangle, I know that that side's 15 and this side is 21. And in the pink triangle, we have 5 and 7. Okay, so I can take a look at my corresponding sides. So if I list them out from shortest to longest, I have 15 and 21 from the blue triangle. And then in the pink triangle, I have 5 and 7. So the question is, are these two ratios equal to each other? And so I simplify them, and 15 over 5 reduces down to 3, and so does 21 over 7. And that proves that they're corresponding. Corresponding and proportional, right? So I've got pair of congruent angles. I've got the pair of congruent sides, so I can say these are similar by side, angle, side. Okay, and there are three ways that we can prove similarity. We can prove two triangles are similar using the angle-angle similarity postulate, which basically says that I need two pairs of corresponding congruent angles in order to say triangles are similar. I have the side angle side similarity theorem, and that's what we just saw with our little cartoon. Okay, remember side angle side, the angle, and the sides, like they have to be connected like that. And then I have side similarity theorem. This is when you're given information about all three sides. I would list out the sides from shortest to longest for each triangle, reduce all the ratios, and if they're the same, the triangles are similar by side. So let's take a look at some examples here. Are the two triangles similar? Explain your reasoning. If they are similar, identify the similarity theorem and complete the similarity statement. Okay. So number one, they want us to take a look at triangle TSR, and TSR is the whole big triangle. Okay, so TSR is the whole big triangle. And then there is a second triangle in this diagram, and that would be triangle TMN. So what do you notice when I highlight them like that? Okay, so you should have noticed that angle T is a shared angle. So I know that angle T is congruent to itself. Remember, that's like reflexive is what we called it when we wrote proofs. And then I'm given information about sides. So I should look and see if the corresponding sides are indeed proportional. So when I take a look at that green triangle, okay, my two sides are 9 and 12. So I'll list those out, 9 and 12. And then looking at the yellow triangle, I need to write down what corresponds to those two sides. So the 9 and the 18, they correspond to one another, and the 12 corresponds to the side that's 24. Okay, so the question is, are these two ratios equal to each other? That is the question. And so when I reduce 9 over 18, I get 1/2. And when I reduce 12 over 24, I get 1/2. Okay, so what this proves is that the corresponding sides are proportional. So I can say that, yeah, these two triangles are similar by, and I've just proven side angle side. Okay, and then to complete my similarity statement, remember order is important. T corresponds to itself, angle S and angle M, and then R and N. In problem 2, I'm given information about all three sides of each of these triangles. So I should look and see if side works. So I'm going to list out the sides of triangle ABC from shortest to longest. So 20, 22, and 28. And then I'm going to do the same with my other triangle, shortest to longest. So shortest is 50, followed by 55, followed by 70. And so I want to know, do all three of these reduce down to the same similarity ratio? Once again, that is the question. So 20 over 50 reduces down to 2/5. 22 over 55 also reduces down to 2/5. Does 28 over 70 reduce down to 2/5? Well, both of them are divisible by 7. So I would have 4 over 10, and 4 over 10 is indeed 2/5. So I can totally say that these two triangles are similar by side. I proved it by showing all three ratios had the same similarity ratio. Now I just need to write my similarity statement, okay? So what I could do, like angle A here is in between my shortest side and my medium side. So that would be V. Angle B is in between the medium and the long side. So that would be U, and then T. Awesome. So in number 3, it says that ABCD is a parallelogram. Explain why triangle ABC is similar to triangle BGF. So let me highlight these, okay? So here we have, I don't think that's supposed to be triangle ABC. I think it's supposed to be this one here because ABC isn't a triangle. So I bet that's a typo, and I bet we're supposed to be looking at these two, okay? So what do you notice? Oh, yeah, vertical angles, good old friend of ours. So we can say that angle DFE is congruent to angle BFG because vertical angles are congruent, right? What else? That's right. They told us ABCD is a parallelogram. So I know that in a parallelogram, both pairs of opposite sides are parallel. Throw in a diagonal, and you get alternate interior angles, which we know are congruent, okay? So I know that AD is parallel to BC because that's part of the definition of parallelogram. And because those sides are parallel, I know that angle ADB is congruent to angle CBD because of the alternate interior angles theorem. So I can say that these two triangles, and that really shouldn't be ABC, BGF, so that would be DEF, right? I can say that these two triangles are similar by angle, and I proved it in my explanation below. So let's check out number 4. Given angle ACB is congruent to angle AED. Explain why triangle ABC is similar to triangle BGF. Once again, I really think I have another typo. Wow, 2 for 2. Way to go, me. So I think we definitely want to work with ABC, but then we also want to work with this little triangle here. Yeah, I'm doing awesome, right? So what do you notice when I trace out those two? Yeah, in addition to having the given angles congruent, they also have angle A congruent to angle A. It's a shared angle. We call that, in a proof, yikes, we'd call that reflexive, right? And so these two triangles are similar by angle, angle. That one was kind of easy, wasn't it? Okay, and so that's how we prove that two triangles are similar. So we can prove two triangles are similar using the angle-angle similarity postulate, the side-angle-side similarity theorem, or the side-side-side similarity theorem. And that's how Backer breaks it down.